Welcome back to the deep dive. This time, we're taking you on a journey through the world of language models. Specifically, a new architecture that's been generating a ton of buzz, um, large concept models, or LCMs.
That's right. You can think of it as a completely different way of approaching how machines can understand and generate language.
Exactly. We've got a stack of research papers and technical breakdowns, but don't worry, we're here to distill it all down. To the key takeaways, we'll give you the aha moments without getting lost in the jargon.
To understand what makes LCMs so unique, we need to first look at traditional large language models, the LLMs.
Okay, let's rewind a bit. Everyone's talking about LLMs these days, but where do they fall short?
We'll think about it like this. Traditional LLMs work at the level of individual words or tokens. It's like they're piecing together a puzzle without seeing the full picture.
So if I'm writing an email, the LLM is focused on each word I type, not the message as a whole.
Exactly. That's where things get interesting with LCMs. They operate at the level of concepts, which are more like complete thoughts or sentences.
So instead of focusing on cat sat mat, an LCM would understand the concept of the cat sitting on the mat.
Precisely. And here's where it gets really interesting. This shift to conceptual understanding means LCMs can be language agnostic. They can work with different languages without needing to be trained on each one separately.
Wait, hold on, let me see if I'm getting this right. You're saying I could train an LCM on English text and then use it to summarize a Spanish article without any extra training.
Exactly. That's the power of operating on concepts rather than words. It transcends the limitations of individual languages.
Okay, that's mind-blowing. This concept thing is starting to make sense, but how does it actually work? What's going on under the hood?
LCMs rely on something called a sentence embedding space. In this case, it's called sonar. Imagine a massive library where each sentence, each thought, is stored as a unique code. That's what sonar does.
So it's like every sentence has its own fingerprint in this library.
That's a great analogy. And get this, sonar supports over 200 languages
Okay.
in both text and speech format.
Seriously, 200 languages? This is starting to feel like something out of a sci-fi movie.
It is pretty remarkable, and this ability to work with so many languages is a key part of what makes LCM so exciting.
Okay, I'm following so far. We've got these LCMs working with concepts instead of individual words, and they use this sonar thing to understand and generate language in a ton of different languages. But how do they actually do that? What are the different types of LCMs?
There are a few different approaches, each with its own strengths. One is called the base LCM. It uses an architecture similar to traditional LLMs, but with a key difference.
What's the twist?
Instead of predicting the next word, it predicts the next sentence embedding. It's like trying to guess the next complete thought instead of just the next word.
So it's thinking on a higher level.
Exactly. Then there are diffusion-based LCMs. These are even more fascinating. They use a process of adding noise to a sentence embedding and then trying to denoise it to get back to the original meaning.
It sounds a bit like a game of telephone. You start with a message, it gets distorted along the way, and then you try to figure out the original message.
That's a pretty good analogy. Now, the interesting thing is there are two main types of diffusion-based LCMs, one tower and two tower.
Why are there two types? What's the advantage of having separate models for noising and denoising?
That's a great question. In a one-tower model, a single transformer model handles both the noising and denoising processes. Think of it like a single team responsible for both scrambling and unscrambling a message.
Okay, and the two-tower model?
In a two-tower model, there are separate transformer models for each process. It's like having a specialized team for scrambling the message and another specialized team for unscrambling it.
So it's all about dividing and conquering.
You could say that. Each approach has its pros and cons, and researchers are still exploring which is most effective for different tasks.
And what about these quantized LCMs I've seen mentioned? What makes them stand out?
Quantized LCMs introduce a clever trick. They take these sentence embeddings, which are like points in a continuous space, and they discretize them.
So instead of being like a smooth gradient, they're more like distinct points on a grid.
Exactly. This quantization allows them to use techniques like temperature and top case sampling, which are ways to control the randomness and diversity of the generated text.
So they're adding a bit more control and predictability to the process.
Precisely. And there are two main types here as well, Quant LCMD and Quant LCMC. They differ in the specific targets they use during training, but the main idea is the same, quantization for better control.
Okay, I think I'm starting to wrap my head around the different flavors of LCMs.
Yeah.
It's amazing how researchers are coming up with all these different approaches to this concept-based language modeling.
It really is a testament to the ingenuity in this field.
So we've talked about how LCMs work at a high level and different types. Now I'm really curious to see how they actually perform in practice. Can they really deliver on all this promise?
That's a great question. And that's exactly what we're going to dive into next. The research papers we have highlight some truly impressive results and exciting applications.
All right, I'm ready to be impressed. Let's get into it.
One of the most striking findings is what we call zero-shot generalization. Essentially, LCMs can perform tasks in languages they haven't been specifically trained on.
Wait, really? So you're telling me I could have this whole deep dive translated into, say, Mandarin, without needing a separate model for each language?
You got it. Think of the implications for global communication, research, even entertainment. The time and resources this could save are enormous.
That's absolutely incredible. It's like they've unlocked some fundamental understanding of language itself, not just specific languages. This is way more than just a fancy translation tool, isn't it?
You're catching on quickly. It's about understanding concepts and meaning across linguistic boundaries. And that's not all. LCMs are also incredibly modular and extensible. This means you can easily add new languages and even new types of data, like audio or images, to the system.
So it's like a language AI system that's constantly evolving and adapting. It's not limited to what it was initially trained on.
Exactly. And when it comes to performance, LCMs are already showing serious potential. They've achieved impressive results in tasks like summarization, particularly for long documents.
So they can help us tackle those lengthy reports and articles we all love to avoid.
Precisely. They can extract the key information and present it in a concise and understandable way. Plus, they're showing promise in a relatively new task called summary expansion. This involves taking a short summary and creating a longer, more detailed text from it.
Interesting. So they're not just condensing information, they can also elaborate and expand on it. It's almost like they're filling in the gaps and creating a more complete picture from a few key points.
That's a great way to think about it. This capability opens up all sorts of possibilities for content creation, storytelling, even personalized education.
This all sounds incredibly promising. But let's be real for a moment. Every technology has its limitations. What are some of the challenges with LCMs?
Of course, no technology is perfect. One of the main challenges is that LCMs rely heavily on the quality of the embedding space, which in this case is sonar. If the embedding space isn't accurate or robust enough, the LCM's performance can suffer.
So it's like building a house on a shaky foundation. If the foundation isn't solid, the whole structure is at risk.
Precisely. Another challenge is the sheer complexity of predicting at the sentence level. Language is nuanced, and capturing all those nuances and subtleties in a sentence embedding is incredibly difficult, even for humans.
Yeah, that makes sense. There are so many ways to express the same idea, so many different layers of meaning. It's a tall order for any model, even one as advanced as an LCM.
Absolutely. And then there's the issue of computational efficiency. Training and using LCMs can require a lot of computing power, especially compared to some traditional LLMs.
So while the potential is huge, there's still work to be done in making them more accessible and scalable for wider use.
That's right. Researchers are actively working on optimizing these models and finding ways to make them more efficient.
Okay, so we've talked about the good and the bad, but what about the future? Where do you see LCMs going in the next few years?
The future of LCMs is incredibly exciting. I think we're just scratching the surface of what's possible.
I'm all ears. What kind of possibilities are we talking about?
Well, imagine a world where interacting with computers feels truly natural and intuitive, where you can have conversations with machines that understand your intent, respond in a meaningful way, and even anticipate your needs.
That sounds like something out of a science fiction novel.
It does, doesn't it? But it's closer than you might think. LCMs could revolutionize how we interact with technology, from virtual assistants that are genuinely helpful to educational tools that personalize learning in ways never before imagined.
I'm starting to see why you're so enthusiastic about this technology. It really does feel like we're on the verge of something truly transformative.
We are. And here's another exciting avenue researchers are exploring: integrating higher-level information into LCMs.
What kind of information are we talking about?
Think about things like topic descriptions, outlines, or even emotional context. Providing LCMs with this kind of guidance could lead to even better performance and more nuanced text generation.
So it's like giving the LCM a roadmap or a set of guidelines to follow. Instead of just predicting the next sentence blindly, it has a deeper understanding of the overall context and purpose.
Exactly. This could be a game changer for tasks like creative writing, where capturing tone, style, and emotional nuance is crucial.
It's incredible to think about the potential impact. But as we've discussed, there are also challenges and potential downsides to consider.
Absolutely. As with any powerful technology, it's crucial to develop it responsibly and thoughtfully.
Well, this deep dive has been incredibly insightful. It's clear that LCMs are a major leap forward in language AI, and I'm eager to see how they continue to evolve.
Me too. It's a fascinating time to be following this field.
It feels like we're witnessing a paradigm shift in how we think about language and artificial intelligence.
I agree. The ability to understand and generate language at the conceptual level opens up a world of possibilities.
Okay, so we've explored the technical side and the potential of LCMs. But what does this all mean for us, the everyday users? How could LCMs actually impact our lives?
That's the question, isn't it? The impact of this technology could be far-reaching, touching nearly every aspect of how we live, work, and communicate.
Can you give me some concrete examples? I'm having trouble wrapping my head around what this could look like in practice.
Absolutely. Let's start with communication. Imagine a world where language barriers are a thing of the past, where you can seamlessly communicate with anyone, regardless of their native language.
Okay, now that would be a game changer. No more fumbling through translation apps or relying on awkward hand gestures.
Exactly. LCMs could power real-time translation tools that are so accurate and natural sounding, it would feel like you're all speaking the same language.
That's incredible.
Yeah.
What about education? I can see how LCMs could be transformative in that field.
Absolutely. Imagine personalized tutoring systems that adapt to your individual learning style and pace, or educational games that are so engaging and immersive, learning feels like an adventure.
That would make a huge difference for students of all ages. It could really make education more accessible and effective.
Precisely. And let's not forget about entertainment. LCMs could create entirely new forms of storytelling, where the lines between reality and fiction blur.
Interactive stories that respond to your choices. That sounds amazing.
It does, doesn't it? Imagine a video game where the characters and plot adapt to your decisions in real time, or a virtual reality experience where you can have meaningful conversations with AI-powered characters.
The possibilities are mind-boggling. But with all this talk about the amazing things LCMs can do, it's important to remember they're still tools. It all comes down to how we choose to use them.
You're absolutely right. As with any powerful technology, we need to be mindful of its potential impact and use it responsibly.
This has been an incredible deep dive into the world of LCMs. It's clear this technology has the power to reshape our world in profound ways.
It's been a fascinating exploration. The future of language AI is unfolding before our very eyes.
So what do you think? Are LCMs the future of language AI?
They certainly hold immense potential. They offer a unique and powerful approach to language modeling that goes beyond the limitations of traditional methods.
It's exciting, isn't it? It feels like we're standing at the edge of a new frontier.
It is, and the journey is just beginning. As research continues and these models evolve, who knows what incredible things we'll be able to achieve.
It's been a pleasure diving deep with you, and to all our listeners out there, keep those brains curious.
There's a whole universe of knowledge waiting to be explored.
Thanks for joining us on the deep dive. We'll catch you next time.